Good morning, everyone. I guess we will start in the next 1 minute from now, sharp at 11. Yeah, we are good to go now. So, hello, good morning, everyone. This is Jay Lakhani here, Learning and Development Manager and one of the instructor at Udaan Aviation Academy, and your host for the day. Firstly, I welcome all participants on board at this exciting webinar on the topic Aircraft Electrical System Integration, a System Thinking's Approach. The idea and motive behind this is to learn ways and to explore more about various systems that are integrated in an aircraft and the factors to be taken into account while the designing and certification phase, and of course the human factors part of it. For catering the purpose, we have an eminent speaker with us today. We welcome Mr. Arjun Vijayanarayanan right from the States. Welcome, Arjun. Welcome on board. Giving a brief introduction about him, Arjun is an aviation and aerospace industry professional with work experiences in roles such as aircraft electrical system design and integration engineer, electrical wiring interconnection and systems engineer, and aircraft certification project engineer. Arjun has two Master of Science degrees in aerospace and engineering and human factors and systems from Embry-Riddle University, Aeronautical University from Florida. Arjun currently works at Viasat Incorporation as an aircraft integration and certification project engineer, integrating Viasat in-flight entertainment and connectivity equipment for satellite communication, high-speed internet, in-flight entertainment on commercial, business, VVIP aircraft. He has also been in he has also worked with companies such as Boeing, Gulfstream Aerospace, GDC Corporation Techniques, Caterpillar, and Safran Engineering. His domain interest also lies in the aerospace industry. He is a member of American Institute of Aeronautics and Astronautics AIAA and Universal Association of Mechanical and Aeronautical Engineers UAMAE. And the list is long and endless and it goes on and on. This is what I could just put in short span of time. We once again welcome you on board at this platform, Arjun.
Thank
Before
you.
we move on with this, I would request everyone to mute themselves and maintain the decorum of the room. Keep your questions handy for the Q&A round, which is supposed to be conducted at the later stages via chat box sections. So yes, that's it for me. I would request Arjun to take over the screen sharing. The access is given to you now, and the stage is all open to you, Arjun. Thank you.
Thank you, guys. Can you guys see my screen?
Yes, it's clear.
Hey, good morning, everyone. I hope you're all having a great Sunday so far and hope you're all well. Before I begin, I would like to thank Jay, Subhashish, and their team from Udaan Aviation Academy for giving me this opportunity today to speak to you all about a systems thinking approach to aircraft electrical system integration. Let's get started. So just a bit of background before we get into the core of the topic. I would like to present the Standish Chaos Report. Uh, this company collects data from all over the world and over 300,000 projects every year, and they published this report called the Standish Chaos Report. As you can see, from the year 1994 to 2015, the percentage of challenged projects have always been higher than the percentage of successful projects. Challenge projects being the projects which were completed but with an overshoot on budget and schedule. Successful projects, of course, were projects that were successfully completed within budget and within schedule, and failed projects, the projects that were scrapped even before completion. Now, when we looked into the reasons behind why such a state or why such percentage increase exists for the challenged projects, we unanimously saw in all of these projects that there was a focus on the managerial part of the system, which is the budget and schedule, and the technical aspects of the system. So as engineers, we get very interested on the technical aspects, the design features, how a certain analysis was made, and technicality and design and technical aspects excite us to a point where we completely neglect the social or human aspects of the system. And the other thing that we found was there was a complete neglect of the relationships and the dynamics between the system elements. An example here is, when we are performing an aircraft integration or any project, we focus mainly on what the requirement is for our team, say, for example, the electrical team. And to the most part, we don't consider how other team requirements may affect us or how our team requirements may affect them. We get completely engrossed on what our system features are, and we start looking at the system more from, if you're in the electrical, more from the electrical system side, or if you're a mechanical, you start looking at it from the mechanical side, but hardly any attention was paid between how the teams and how the system elements all affect one another. So before we proceed into the project, I'd like to ask a question as a poll. Approximately what percentage of maintenance errors do you guys think is attributed to human factor errors? So as we can see that 80% is the right answer here. Which, if you think about it, if 80% of human, like in aviation maintenance, 80% of errors are because of human factors errors, then as already you can see the importance of attending to human factors in our day-to-day activities, and we're going to see how. So let me introduce to you all to holistic systems thinking. In this systems thinking approach, a system consists of people first, and then structures and processes that work together or work cohesively. As you can see, right away, there is an importance given to human factors. And the bigger aspect of the holistic systems thinking, this is what holistic mean, is the components of a system can be best understood in the context of relationships between each other rather than in isolation. And here is where I spoke about looking at electrical systems and mechanical systems and structural systems or maintenance related factors separately rather than how they all talk to each other. And so the main factors between systems thinking and traditional design thinking is the inclusion of human factors, and looking at system holistically means how system elements talk with one another rather than in isolation. So now that we know what holistic systems thinking mean, and now that we know the limitations of traditional design, let's see how we can approach aircraft electrical system integration based on holistic systems thinking. Now, with any aircraft electrical system integration design, here are the factors or here are the requirements that has to be considered by any designer for a good product or for a good aircraft system integration design. These requirements are as follows, which is customer and contract requirements, budget and schedule requirements, FAA, EASA, DGCA, any cert authority requirements, human factors requirements, system integration requirements, system installation requirements, software testing requirements, and lastly, the maintenance requirements. And let's see how what these are and how to include systems thinking approach into all of these. So the first one we are going to look at is the customer and contract requirements. If as a design engineer or your team, you can approach your project manager or the program manager to go and see if you have access to looking into the statement of work or a signed contract between your company and the customer's company. Here, you can see what the customer requirements are and make sure that you understand the customer requirements and how it applies to your design. If you are an electrical system integration engineer or the mechanical engineer, once you read what the customer expectations are, then you can start looking into how to incorporate that and how your team has to do work to make sure you meet the customer expectations. Right. So on your right, you see a picture. This was an aircraft which we delivered to a Saudi Arabian king back when I was in GDC Techniques, and right away you can see how luxurious this VVIP aircraft is. Once you get into VVIP aircraft or the business aviation sector, this is a very common sight where there are like all kinds of systems and luxuries inside a VVIP aircraft. And since these are like VVIP names, you want to make sure that you give them with the best product possible because the name spreads amongst the VVIPs very easily. And you want to make sure that your company has a good first impression made on such VVIPs because these are big businesses for any company, right? So once you have say this aircraft had an aquarium inside the aircraft and you want to make sure, okay, has this been done before? What kind of FAA regulations or EASA regulations should we cater to coming from the cert side? Do we have a design that we know which will work for this particular aircraft interior, which can be found in the approved aircraft interior configuration document or LOPA? So you want to make sure you understand each aspect of the customer expectation and how to change your design or how to develop your design based on the customer expectation. And another example I can give you is I was fortunate enough to work on Air India One, which just got delivered to India. GDC Techniques was the company which I worked for to work on Air India One as well. And here was a unique challenge because here was a head of the state aircraft, and we had to undergo a different training to make sure that we understand the secure systems of the aircraft, secure communication systems, because it's a head of the state aircraft. We also work on Air Force One, which is the United States President's aircraft, and the requirements change massively. And since you can't talk about this, I just wanted to let you know that every aircraft customer has their own expectation, and as design engineering teams, you have to make sure that you are trained or you are given good enough knowledge to make sure that you have a good design that you can come up with for this particular aircraft. And more importantly, to make sure your design caters to the aircraft schedule and to the design caters to make sure they have a good customer expectation. The next one is the budget and schedule requirements. Again, these can be found in statement of work, or you can talk to your program manager or project engineer and they will be able to give you what is called a um, project specific certification plan, which has certain schedule in it, or just a project schedule for the particular aircraft. Now, this document gives you an idea on when the aircraft is going to be inducted into your hangar, when system installation testing are going to be performed, the installation schedule, when the certification authorities, DERs, DARs, ARs, when are they going to be available in your hangar to make sure they go through their compliance and conformity, and to make sure that all the STC documents or the TC documents in certain cases are going to be developed and submitted to the FAA, and when the aircraft is going to be returned to service. This is important because there have been a few cases at Gulfstream when I was working at Gulfstream where um, a certain design we had to take. It was a complicated design for one of the Qatar aircraft, one of the Qatar executive aircraft, and it required a certain complicated design. Now, there was no communication between the sales and the program side to the design engineering side as to, hey, the aircraft can only be in our hangar for 3 weeks. We didn't know about it. And we all were the thinking that usually an aircraft is going to be there for a month and a half, uh, usually. And we started working on a design to make sure we meet the month and a half schedule, not a 2.5 week schedule. Why this is important is you come up with a complicated design where it's probably going to take the installation technicians for testing, and to just even install these things, it's probably going to take them over 2-3 weeks. But if you're not aware that the aircraft is only going to be there in your hangar for 2 weeks and your design doesn't meet the schedule, then it doesn't matter how good your design is, it's a bad design for the company. Because a company cannot let aircraft delivery schedule slip, because every delayed date is going to be a big money for the company, and the company has to eat all the charges, and the customers usually charge like crazy for every single lost working day for them, right? So if you know that your project or your design is going to take a certain amount of time, you need to communicate that to your project engineer or program manager that, hey, this design is going to need 3-4 weeks for installation, right? So they can plan accordingly to let the customer know that, hey, we need month, or we can install half of the equipment, do certification, and once certification is okay to return the aircraft to delivery, they can come back again in a month or two whenever they have their downtime and finish up the installation. So this is why understanding budget and schedule requirements for designers is very important. Next comes the certification requirements. Irrespective of which certification authorities that you may be involving yourself with, whether it's the FAA, EASA, DGCA, I have been lucky enough to have communications with all the three, and you want to understand what the differences are between working for an FAA, between working for EASA and DGCA. But in all of the three, what I have seen is it's very useful and important to bring in the certification authorities early into your design. You want to make sure that you let them know what you are thinking as a design, what you are thinking for aircraft modification, what kind of systems are required for this aircraft modification. If you have to develop a new product, what kind of new product are you developing, so that from them you understand what kind of certification regulations that you have to meet, right? Because every single design factors has some certification implications, has some certification regulations that you are showing compliance, which the certification authorities can find compliance from. right? So when I started off, it was, I wasn't really aware of how these certification regulations applied to my drawing, right? I'm going to talk from the FAA perspective because that's what I'm used to. Say, for example, I was always wondering why we put in certain information on the on a wiring diagram. Say, for example, why do I put a line here? Why is a wire number important from the certification perspective? Why should I provide them with the amperage information, or things like that? And until I went for a training called the method of compliance training, I had no clue that every single line on your wiring diagram, and this is the same for 3D mechanical design or structural drawing, every single thing you put in your drawing actually has regulation impact, actually show compliance to a particular regulation, right? For example, putting a wire number there, it's not only for wire identification, but it's also to show compliance for 25.1301, 14 CFR Part 25 .1301 requirements per the FAA guide. I had no clue about these things, because if you look at 1301, it doesn't tell you, to say that you need to show wire number, right? It doesn't tell you that, but it talks about identification. So you want to, and we always, we go to a training where we say, here are all the regulations. And, as engineers, you're not expected to understand and interpret all of these things, because there are experts, certification authorities who are experts in that. But it's very important to attend a training to see how certification regulations are transferred into your design. Once you get that connection, you don't need them anymore to tell you, hey, this is wrong, this is right, because it clicks, because you understand what they are looking for, and then you start putting that into your design, and you become a good all-round designer. And that is the importance of holistic systems thinking, right? So where can you find certification requirements? Certification authorities develop this plan called the certification plan, or the project specific certification plan. Here, they let you know what certification strategy they are going to use to approve this design or approve this modification on an aircraft. And then you can look into type certificate or supplemental type certificate requirements. What kind of component qualifications are they expecting, right? Which is, I am expecting DO 254 Rev C on my component qualifications, or I'm expecting DO 160G on component qualification, things like that, or DO 178C as component qualifications. You need to understand that, because if you are going to develop a new product, or if you are going to use a particular component which is only DO 160E compliant, then at the end, when certification is going through after things have been implemented, they're not going to be happy to say that, hey, I was expecting 160G and you've only showed me 160E. And at that time, if they're going to say that, certain ODAs do that, where they're like, I need 160G, you need to go back to your suppliers and make it happen. Now we need to go through extra qualification testing, which is not a 1 day, 2 day time. You need to have qualification reports developed, or you need to make sure that, you show similarity to let the certification engineer know that, hey, this is fine for the aircraft. So you want to understand all of these things. Next, the certification plan talks to you about the drawings you need to create, test plans you need to create, substantiation documents that they require. And on the compliance checklist on the next line, they show you how each and every document you create are showing compliance to particular FAA regulations or EASA or EASA regulations. So you right away understand this is why you are creating such a document, to show compliance to a particular reg. It also talks about which unit member is going to be responsible for what kind of conformity or compliance, whether it's a structures unit member or electrical systems unit member, EWIS unit members, aerodynamics or HERF unit members, etc. And then they also talk about certification schedule. And you want to make sure your documents are ready as per the certification schedule, because they are required to send in their certification plan for FAA approval, any EASA approval, or any cert authority approval, whether a month prior, 2 months prior, 3 months prior, depending on how the situation is in your particular company or in your particular country. They make sure they send in their certification plan early to be approved by the FAA or any certification authority or regulatory body, and then it gets back to you. So you want to make sure you keep providing them with the information as and when their certification schedule goes through, because certification is not easy. You want to make sure you understand that. And this is the same for maintenance, maintenance quality inspection as well, because finally, they are going to find compliance. You're going to show compliance through your drawing, but installation conformity is also required, right? So you want to make sure that as design engineers, you also go have communications with the avionics installation technicians or structures or mechanic installation technicians, and make sure that they understand your design properly, because at the end of the day, they are the people who are installing your system, and that's the people the QC is going to be found on, or conformity is going to be found on, because they see if the installation conforms to your design. And if you guys don't have proper communication between one another, and the installer goes and does something and your design is not matching, or the installer does the right thing, your design is wrong, but still the design doesn't match the installation, then the company as a whole is in danger of project slippages or aircraft delivery slippages. It's very important to make sure that you have communications with the technicians or the floor, to make sure your design matches them. And you can do it as a company. You don't need a certification body to go tell you that this is what matches. And here is where holistic systems approach comes in again. So before we proceed, again, according to you guys, which human factors do you guys think were neglected in the 737 MAX cases? Let the polls begin. That's great. So I see a higher percentage on reliability, on automation. Again, if you guys think about it, that's what you heard more on the media. And then, that's probably the first time where a lot of you guys would have gone and gotten excited about what an MCAS is and how MCAS works and things like that. Again, as you can see, the psychology behind having interest in the technical aspects of the system, like I had mentioned before, and I was expecting this, but all of the poll results there, or all of the poll choices there, had a big impact finally on all the the unfortunate happenings of the crashes. There were pilots who let Boeing know that, hey, we need something, this is probably not going to work for us and we need a fix. And there were like simulators which were missing, and simulations that were missing the actual scenario of an MCAS issue. Some countries did not even have proper simulator trainings, as you guys would have probably known, and pilot training, right, which comes into type rating and all of that. But a big thing is also certification. There has been a big push for human factors and certification now with the FAA, and they are also talking about how to include human factors in certification, which is unheard of, and how to include systems thinking approach into certification as well. Because if you guys know a lot of what happened when the FAA said, hey, we were not aware of some of these design considerations right off the bat, then you guys realize that there is a certification impact which was neglected, right? This can again come into feedback, like 18% of you guys have mentioned. But usually, cert authorities are left aside to do whatever they want to do. And as design engineers, we always think that, I'm going to finish my job based on my design requirements or based on my company's handbook, or worse, this is how things have always been done, and this is how I'm going to do it now, right? Rather than thinking how my design affects other people design and how my design affects certification. Why am I putting this line here? Why am I providing on my material drawing? Why am I providing with material information? Because when you go to the FAA regulations, it talks about flammability requirements, right? And if you don't know, or if you don't understand this is why you are providing certain information, a lot of you guys as design engineers, we always think that, man, this is so much of work to do. Last time I didn't put this, it didn't become a problem. This time, no problems, probably not going to be a problem, but it does. Once you understand why you are putting certain information into your design, it clicks. And that's the kind of education or awareness that as design engineers, as organizations, that kind of awareness culture or training culture need to start being developed. And personally, that kind of an awareness or education has helped me a lot in grooming me as a holistic systems thinker and a holistic systems designer. And that is why, um, that's the takeaway I want you guys to have after this session. If not for anything, take that holistic systems thinking approach as your carry forward from now on. Now, going back to the design requirements, next one and the most neglected one is the human factors requirements. Um, the best human factors that you can see in any aircraft is the cockpit. Right? Once you study human factors, once you study aviation human factors from an application point of view, you are amazed on the kind of experiments, human factors experiments, pilots have to go through, human factors engineers have to go through, and cockpit design has to go through, avionics design has to go through. I have had first-hand experiences in my test labs at Gulfstream and at my university at Embry-Riddle Aeronautical University, first-hand experiences on how some of these works, and I'm going to share that example with you guys. Now, first example being on top, that's one of the Gulfstreams that I had the opportunity to work on, which is the G6 Gulfstream, which is the G500 or the G600. And on the bottom was how, the bottom is not a Gulfstream, but the bottom is also how Gulfstreams looked on the Gulfstream 450s and the Gulfstreams 550s. Right away, you can see that the newer Gulfstreams have touchscreens completely, and you don't see regular switches, regular circuit breakers, and any physical things that we as humans are used to. Everything has been completely transformed into user interface or touchscreens, right? Right away, on our first test flight, we had this feedback from pilots that, when I press a switch, I know that I have pressed a switch, right? Because there is an on off or there is a push button. And they were like, now when I press a touch screen, I don't know if I have pressed it, right? I know I have pressed it, but I don't know if I have activated the particular feature. And so this accounts for a human factor called tactile feedback. So if on your Apples or your mobile phones, when you touch it, you can have a feeling back that you know that, when you touched it, an action has happened. This is called a tactile feedback. And so we had to incorporate tactile feedbacks on these touchscreens as well to make sure the pilots feel comfortable that they have indeed activated a particular feature. Next ones where in a particular scenario, right? Say, for example, a failure has happened. And so these are intense scenarios which the pilot and the co-pilot have to go through, right? And, I was again fortunate enough to be a part of this research where the pilots complained that certain switches, when we are only given 10 seconds time or 15 seconds time, when an issue is happening, when a adverse scenario is happening, we only have 10 seconds to look at where some of these things are, and we don't have enough time to go through everything, search for a particular thing, and go ahead and press the particular switch, right? So as human factors engineers, we actually had to track the pilot eyeball movement. So for 10 seconds, we tracked how the pilot's eyeballs moved, and not just few pilots. We invited a lot of pilots from FAA and from Europe to see if cultural differences play a part in eyeball movement and what you look for and training and everything. So based on pilots' eyeball movements, we had to place certain switches at certain locations which are accessible for the pilot or the co-pilot, and this is also human factors. And once you locate a switch, if you have 15 red switches all having the same font and all having the same shape, again, that is a problem, right? So there is a big human factor behind the font of particular placards. What color switches are they? What color font sizes or what color font are you using, etc. All of these are human factors, and all of these make for a comfortable pilot experience, which is absolutely essential when an aircraft goes through adverse scenarios. And the next big one was the automation. So, back in 2011 or 2010, I was introduced into this next generation air traffic management system, which is the ADS-B, ADS-C, when it was in the infant stages, and Embry-Riddle had a big part in the earlier developments of the next generation air traffic management systems. Now it is 2020, which is by when the ADS-B was mandated here in the US, or aircraft flying in the US. So it's nice to see how a project which I was involved in their infancy stages and how it has developed now. So on this project, this is where the air traffic management system and their communications to the pilot was completely automated. So we, and this was what my thesis was based on. So we interviewed and invited pilots from the FAA, pilots and air traffic controllers. We simulated an environment. The first day was briefing them about what they're going to be looking at. They were going to be performing their own jobs, right? So we had a good flight simulation center at Riddle. So the air traffic people are going to be doing what they do every day. The pilots are going to be doing what they do every day on a simulator. So the first day, we introduced certain pilots of different ages, because age is a big human factor to consider. And we let them know, go through with your motion and see how you work with the system. After like a few hours, since it's completely automated, few pilots just got bored. They didn't know what to do. They were bored. They actually left for a smoke break. And some air traffic controllers, again, they didn't know what to do, but some people were playing with the system to understand the manuals and everything. And some people were not comfortable with it because everything is automated and they are not comfortable with automation. And some people completely trusted automation. And so every day I would go in there and interview all the pilots and all the controllers on what's their feedback, how they use the system, how it could be improved and things like that. The next day, we suddenly put in a simulation for an imminent aircraft accident or aircraft crash in the sky. You should have seen the intensity rise in the pilots' faces, because they didn't know how to handle the system, because they were completely new to the system. Even though trainings were provided, they didn't understand it, they didn't ask questions, and they were like, oh my god, my aircraft is crashing, now what to do? And immediately started arguing and shouting, and it became like an actual cockpit or actual controller's room. They didn't know what to do. Certain pilots who took the time to understand, they were able to avoid the crash. Certain people crashed. ATCs were being tensed. And here is where the big thing of trust in automation and how automation affects people. Some people don't trust it. It completely bores out a lot of people, because here I'm used to doing all of these things manually, and now a system's doing, and I'm bored. I'm completely bored. I don't know what to do. I'm going to change my job. So all of these come in as human factors requirements for testing, for certification, and for even for maintenance, right? When you look into an aircraft hangar or maintenance engineers, you always see that you have certain sized people for certain tasks, right? You may have a person with long arms who can put his arms into like a leading edge of a particular aircraft and work on something. You may have a short person who can get into certain zones within, whether it's avionics bay or whether it's any part of the aircraft. All of them matter, right? And other human factors that I can talk to you about is, say for example, a person, as you guys saw previously, where 80% of uh, 80% of aviation maintenance errors was attributed to human factors. Again, you can see how training can come into play for a particular technician, how maintenance engineers need to be trained not only to study human factors, right? Because it's easy for anyone to say, here's the waterfall technique, here's the Swiss cheese model, here's the peer model. But if you don't know how to apply all of that in your day-to-day work, then none of that theory really matters, right? So adequate training has to be given to technicians on how to improve on human factors and how to inculcate human factors into everyday design you do. And we're gonna talk about it later. Next comes the bulk of the topic, which is system integration requirements. Today's session is about system integration, and apologize for a highly populated slide, but here are all the system integration design considerations, or as system integration engineers, the process. Here is what you need to do, right? Any system integration, your system installation manual or the operation manual is your Bible. As design engineers or system engineers, you need to know the installation manual inside out. You need to know the user guide inside out, because you are the point focal for the design, and you are the point focal that the installers or certification authorities are going to come to if they have questions about the design, right? On an installation manual, you can find information about power interfaces, data interfaces, interconnect diagrams. So you see how to interconnect or interface your particular aircraft with what the system requires, connector information, approved wiring and mating connector information, grounding and bonding requirements, mechanical requirements. Even though I'm talking about electrical system integration and I'm an electrical system engineer, in my experience, if you understand the other team requirements also, everyone can come talk to you now, because you are open and you are understanding how their requirements affect your requirements, or how you do work affects them, right? Proper communication and team coordination, again, holistic systems thinking. And the environmental requirements, right? If you don't know that your particular LRU or your particular avionics equipment can only be placed in a pressurized zone, and then you are only used to placing this particular box always in an avionics bay or in an unpressurized zone on an aircraft, then right off the bat you are violating the environmental requirements, what the particular box has been certified to, and what has been recommended by the system suppliers. right? You need to understand thermal and cooling requirements. Just because we are electrical engineers doesn't mean that we don't have to understand thermal and cooling requirements or mechanical system information requirements, because everything has a role in, like, for for electrical engineers as well. And then finally, the functional hazards and the system safety requirements. Once you are thorough with the install manual, then the other thing, if you are lucky enough to step on an aircraft, uh, absolutely go do aircraft survey. Here you understand, you have a particular design in your head as, here are all the boxes or LRUs or systems that I need to integrate. Here is where I think it can go, and have a particular design integration design into your head, then perform an aircraft survey. Once you get on the aircraft, some people usually work with pictures that may have been taken a year ago, or some people have software, like back in Boeing, we had the software called IVT, where you don't have to step on an aircraft. Every day, the aircraft interior was being uploaded as pictures or videos into the software, and then without stepping on an aircraft, you can actually visualize the aircraft. But if it's not updated every day, you think that a particular connector can be placed right there, or this box can be placed right there. But if the picture you are working with was taken a month ago, and in between the aircraft has gone through certain modification, and you can't place your system in that particular location anymore, then you have a bad design, and you need to find about this on an aircraft survey. So I always absolutely believe in going to the aircraft, looking at what the reality is, what you are thinking, does it really work? And then make sure you have a thorough aircraft survey. Me personally, what I have found to be absolutely useful was talking to the installers, or talking to the maintenance engineers, or talking to the technicians while I perform my aircraft survey. As design engineers or engineers, I've always seen this ego on design engineers, that, or system engineers, that, hey, I know everything I'm talking about, you guys are just technicians, don't even bother giving me your feedback, I need to tell you what I need to do, and things like that. That doesn't work, right? Because finally, the installers have the real-time experience, or technicians are the real-time people who are going to be installing your equipment, and they know the inside out of the aircraft, because they perform A checks, C checks, maintenance checks pretty much day in, day out, right? So I always insist that we need to talk to the aircraft survey technician, or installers, avionics installers, that here is the design I am thinking about, here is the wire routing I am thinking about, let me know if it works for you, or if you have an improved suggestion, or if you have an easier suggestion. Certain times I have seen that certain, like back at Gulfstream, and other branch of Gulfstream, located in, I was working in Georgia, and there are Gulfstreams completion centers all over the US. So another Gulfstream, they sent us a particular design, and I was the lead for all Gulfstreams put together. So any new product that has to go on the aircraft has to be going through me. And I took it to my technicians here, and I was like, what do you guys think about this particular wire design? Because I found out that, all they had to do was route a wire between the cockpit and the mid cabin of the aircraft. And I personally knew that there was a better way to do this. And the way that was suggested would require the aircraft technicians to go take all the insulation out, take all the headboards out, and do a major, modification to the aircraft just to route two wires. And when I spoke to my technicians, I went on the aircraft. I was like, hey, is there a newer way or better way to do it? And apparently, our aircraft, all aircraft comes with conduits, where you can route wires to these conduits, and you don't have to rip open the headers or any kind of insulation. And these conduits are provided, on your aircraft to route wires automatically. And we sent them this feedback again. Their installers absolutely loved it. and the management had to change the design. And here is where, and as engineers, because we don't work on the aircraft day in, day out, we may not know about all of these things, right? So you want to talk to the maintenance engineers, or you want to talk to the technicians who know the aircraft inside out, get their suggestions on what it is can be done easy. Is there an improved way to do so? And then incorporate all of those into your drawings, which is the next step, which is electrical drawings, mechanical drawings, wire routing drawings. And you do all of these things after you talk to the end user, which is the avionics installers or the mechanical installers who are going to be installing these systems. Again, holistic systems thinking again. Once you have your design, once you put out a draft of a block diagram or a schematic, now instead of saying that my job is done, you need to talk to other engineering teams as well, mechanical design, mechanical systems, flammability, structures, etc., and see if your design actually works, right? Sometimes the mechanical engineers or mechanical system engineers can come tell you that, we thought we could place this box here, but this location is not going to satisfy thermal or cooling requirements for the particular box, right? Because this is not certified to go to take this much of aircraft shock or vibrations, and this is not the particular thing to do so. If you did not talk to them and you went ahead and released your design, thinking that your box is going to be there, you did your wire routing completely, and then you didn't find out till the last moment that your box can't even go there, then you need to go to your drawing board and redo everything, right? But if you involved all of them into design reviews, which we call it sanity checks, and at every stage talking to the other system elements, talking to the installers, and then letting them know here is what we are thinking, and come up with a product unanimously, all of this can be avoided, and you will have a successful project, which is project finished within budget and schedule, right? And next thing is to talking to project engineers or program managers. As technical design engineers, we always think that program managers, he just thinks about management. He may not be a technical guy, so I'm not even going to bother talking to him and stuff, because we are only thinking technical, right? Just because you finished your design, magically the product doesn't arrive from somewhere and then go on the aircraft, right? So you want to make sure that if you choose a particular back shell or connector, if you will, and that's the connector that you absolutely want, and you go let the project engineer know that, hey, this is what I need. And if you find out the particular connector has a 16-week lead time from its suppliers, or because it's not in stock, they need to get it done and they need to qualify it, and it needs to come to you only after 16 weeks. But the aircraft is going to be coming in 4 weeks. And if you did not know about this, then it's a bad design, right? Because at the end of the day, they're going to come back to you, and there's going to be a lot of arguments and finger pointing, which happens in a lot of companies, and you want to avoid that, right? So make sure that once you have a design drafted, make sure you go talk to the project engineer with your bill of material and let them know that, can you find out if all of this are in stock, and can you find out the lead time, right? And then they're going to coordinate with planning and procurement to make sure that everything that you want in your design can be available when the aircraft inducts. And the next thing is new product. Working in the business aviation industry or the VVIP aircraft industry, new product development is not a new thing, because these multimillionaires, billionaires, they come up with a lot of products that they want, and it's actually cool that because you get to work on different new product developments right from the start, right? So if there are no products out there for these particular requirements, you need to send out RFQs or RFPs to various suppliers who may be able to come up with this design, right? So you are involved in technical requirements documentation, you are involved in the RFQs, you are involved in what kind of requirements need to take place, you are involved in prototype development, qualification and testing, etc. And as design engineers, the one who understands the system holistically, once you do that, they will all come to you for everything, because you not only understand your design, but you also understand DO160G. You also understand testing. You also understand mechanical requirements. And it's an easy conversation they can have with you. And before you know that, you will be promoted, which happened to me time and again, right? So talk to the project engineers and program managers, not from a technical point, but just like, here's what I'm thinking. Um, can we see that this meets project and schedule? Is this going to affect our schedule by any chance, etc.? Right. The same goes with lab testing. A lot of customers, sometimes customers ask you to see that, I don't want to test my equipment first on the aircraft. Make sure we can test the equipment first in your lab, get the lessons learned, and then you can go to your aircraft, because I'm not comfortable bringing in my aircraft if this is not already tested in a lab, right? And you have to coordinate that with lab technicians, project engineers, again, to make sure that lab testing is included in the schedule. And if you are involved in lab testing, you need to understand that you probably need to produce a lab drawing, right? Because not always the aircraft drawings apply to a lab drawing. So you want to make sure you specify lab specific drawings. And if you did not know about it till the last second, then you're like, hey, no one told me, but you get the blame, right? You don't want that. Finally, as a company, you want to succeed. And here is where communication and understanding each other requirements and helping each others out plays a big role. And this is, again, holistic systems thinking approach. Right? Once you finish system integration requirements, now you go on to do system installation requirements, which can be found again in the system installation manuals, operation manuals, AMMs, maintenance manuals, or component maintenance manuals, etc., where you not only think about integration guideline, but you also think about installation guidance, right? Which means, from a mechanical's perspective, hey, I need this particular surface to be prepared for grounding and bonding. I need this particular surface to be burnished properly, because my system requires a 2.5 milliohm bonding resistance between the system and the bonding surface. So you need to let them know, and this is installation specific, right? If you did not put that on your drawing, that this particular surface needs to be burnished or prepare for bonding and guiding per FA requirements, so and so, they wouldn't know that. So you need to understand what the installation requirements are, and put that as flag notes or work scope instructions or work instructions for the installers. Right. Again and again, the installers and the maintenance engineers are going to be the final people, hands-on people installing the system, doing maintenance, and you want to make sure that you communicate things to them properly. Next comes, with respect to wiring supports. If, for example, you make sure that your wire routing goes through a specific wire routing path, right? And in your head, you know that, between two wiring supports for an EVIS aircraft, some companies go between 24 inches of separation between two supports. Some companies go as 12 inches between support to support. But if you just assumed that the particular wire routing path has 24, has wire routes all over the place, and you did not specify that on your drawing, when the installers take a look at it, they're like, hey, I cannot put a wiring support in this location, and I can only put it in another location, and it's going to deviate from the 24 inches because it's probably 34 inches. So if you don't talk to them about installation specific requirements, they are probably not going to know about it, and the project is going to be a failure, which is what you don't want. And the other thing which I often see is, all of the system installation manuals comes with, you are working on a complicated system which requires a specific tool that needs to be used to, make sure it's being properly installed, or the torque requirements or the mounting requirements need to be specific. I have seen this happen at Gulfstream, where one of my projects, when I was a new engineer there, you don't think about all of these things, right? So you just specify your drawing, and then on the day I found out that this tool is new. We don't have this tool, and the tool needs to be ordered. So it was a big lessons learned. Me, it wasn't my job because I was on the electrical side, but when I heard that, I always made sure I went and spoke to the technicians that, hey, here is the manual. Do we have all the tools necessary? And it's not just getting the tooling right. It's also, are the technicians trained to use a particular tool? Because if they are not trained, it's probably not going to work, right? Sometimes we actually had to hire a contractor from outside just to use a particular tool just for that particular equipment. It happens all the time, right? So as engineers, you want to make sure you let the installers know that here's what we are looking at. Do we have the proper tooling and training? And if you go talk to them about that, they can tell you, I can probably use something else. Or if this is what you need, let me go ahead and order it and let me train my people to use that particular tooling, etc. Next is the software and testing requirements. Even though, after you specify your wiring drawing or mechanical design, you think your job is done, it's not really, right? You want to make sure you understand the user guide or installation or operation manuals to see if you understand the user interface or troubleshooting and how software is going to affect you, right? For example, if um, if a particular software or firmware did not go through qualification, you would be surprised that even software has I don't know if you guys are aware of PMA, which is parts manufacturer approval. Even software plays a big role in a PMA. If a particular software doesn't go through, if your system has has firmware installed in it, and then one of these firmware did not get recorded or approved as a PMA, you didn't know that, you chose a particular product, you're going to land in trouble with certification authorities, right? You don't have to be an expert in all these software and testing requirements, but you need to understand how it affects you as as electrical engineers or integration engineers, or if you're project engineers, like myself, where you manage all of these projects and different teams, you absolutely need to make sure that you understand all of the team requirements, and it's very important. Next one's a big one, which is the maintenance requirements. Um, Your job as a design engineer is not just complete if they can install a particular LRU into a particular location, right? A good design engineer always thinks about if it can be removed properly, repaired easily, and put back into the same location without any hazards, right? That's human factors thinking. On your right, say, you see an avionics bay, technicians are working on LRUs stacked right next to each other. Say, for example, these LRUs are flight critical LRUs, which means that you are probably not okay even touching it or going anywhere near it, because even though you may be highly skilled, you don't want to touch some of these equipment because you don't want to introduce a failure aspect, because either you forgot it or something happened while you were pulling the box out, etc. Right? For example, if you are thinking about installing a particular relay or particular junction box or a small a switch, for example, and the location that you found was behind these avionics boxes, because that's where a particular you have enough space behind it, and that's where you decided to put, right? So now to access or troubleshoot your system, a maintenance engineer or a technician needs to go through removal of all of these requirements just to be able to access your small box that you decided to put in that specific location. It is one of the most bad designs, because you are introducing failure aspects, because everyone has to go through, just to be access to your system, they have to remove five or six different boxes, right, which you don't want. And so from a maintenance engineering perspective, you want to make sure you understand their requirements and make sure your design caters to easy removal and repair, R&R, and then make sure you put your design according, right? A common example that I see all the time is ground locations. You know, sometimes people put two ground studs between, usually there is a 1 inch gap between ground studs, even though there are electrical and signal uh, thought processes behind why this 1 inch is. But because there is a 1 inch gap, tools are also developed based on having that 1 inch, right? If you don't think about it and then you place two ground studs, say 0.5 inches apart from each other, then a technician cannot use his or her tool to make sure they can remove the ground stud or work with the ground stud, right off the bat. Then you are not thinking about removal and replacement, because they cannot use any industry standard tool, because industry standards tools are designed based on certain FAA guidance. And so there are not only FAA technical guidance that are based on what your design is. There are also installation criteria behind how a tool is developed based on FAA regulations as well, which a lot of people don't think about or even talk about. So always think about removal and repair, and am I going to make it easy for removal and repair in your particular design? Next comes the modular design. Just like how convenient a modular kitchen is, you also want to make sure wherever possible you provide a modular design in your cabin. Right? For example, if you are working on a toilet or a lavatory, say for if you're working on a lavatory, you're going to have shipside wiring or aircraft wiring, which comes into a particular disconnect on the lavatory, and then you have lavatory side wiring, which is interior to the lavatory. Why you have this is because when I have to take the lavatory out, I can just disconnect at the disconnect connector and then just take the lavatory out, and there is no other connection between the aircraft side or the ship side and your lavatory. This way it makes it easy for maintenance to be happening not just on the aircraft but also on the other side of the lavatory to remove the lavatory, right? If you did not think about it and if you did not provide a disconnect now, and the all your wirings goes straight from the aircraft side to your particular equipment that you have placed in the lavatory, it becomes tough, right? Because now they have to go all the way to the ship side to remove certain wiring or to remove certain ground studs and then take the lavatory out, making it hard for them, or introducing failure points again, which you don't want to have. The next is again maintenance that I touched, which is ease for troubleshooting, etc. And some of these or most of these maintenance requirements can be found in the component or aircraft maintenance manuals, and make sure as design engineers you understand that. Now, based on maintenance, pertaining to human factors in aviation maintenance, choose which all factors constitute the dirty dozen. Let the polls begin. Perfect. So, that's right. The 71% of you who have said all the above, that's the right answer. So, go take a look at what the dirty dozen means as it pertains to aviation maintenance. And you can look at 12 human factors which are usually neglected, and that's why they are called dirty dozens. So again, now that we know about the importance of systems thinking, here is a framework that I developed back in my thesis called the systems thinking framework, where the framework is completely based on systems thinking and how every department, how the organization, how different teams actually have an effect on each other or an effect on each other. So on the bottom, you can see technical activities which are being performed by engineers, by technicians, by project engineers, all the technical activities that are being performed. Next rung goes the team processes, where here is all, remember you guys, I spoke about the chaos report and all the factors that we found to be failure factors. So the systems thinking framework was based on the chaos report, was based on our next generation air traffic management projects, based on a lot of pilot projects, etc., where we found out that here, like every box that are mentioned here, are very critical for a successful project to be performed by a company, and how every project or every team affects every other team, and how every team affects every other project role or role within a company, and how everything affects the organization. So with that, I wish to conclude by saying that it is important to consider the requirements of all stakeholders before a design is even started. Then proper incorporation of the requirements along with efficient communication and coordination throughout the process will make for a holistic design. Jay, you can take over.
Well. Yes, that was indeed a great session, I must say. Yes, the backend part of which we are usually not aware when we see an custom aircraft or a BBC liner. Even the macro modification takes hours of design and certification. So yes, it was something very great to learn, and especially as rightly you mentioned the different stakeholders which come into account. And as a designer or as a customizer, a customer, you need to steer around the requirements. So that was a good point for me personally as well. So it's time for some Q&A session. I would request everyone to shoot their questions in the chat boxes. The chat box is open for everyone. We'll have like 5 minutes for everyone to put in their questions. So yes, the chat box is, I believe, is open. Everyone can put in their questions or any queries regarding the session. Meanwhile, I'll request to take over the screen share from you, Arjun. If you could please stop the screen share.
Okay.
Yeah. Yes, I believe it's visible now. So yes, we have 5 minutes for the questions. I see questions roaring in, and meanwhile, while the questions come in, we are happy to announce the batch 2 of our maintenance management course here at Udaan Aviation Academy on the 29th, 30th, and 1st of November 2020. We have a special instructor for the same as usual with an avid experience of 30 plus years in the expertise of maintenance, with a vision to equally learn the managerial aspect of maintenance and to be an alpha among your colleagues, and which is what we introduced this course. The basic idea is to teach students the management aspect of maintenance at day one, where you learn more about car 145 organizations, how does an MRO work, how it is certified, and basic requirements for an MRO, followed by day two, which is purely dedicated to material management soulfully, and where we learn more about what is the cycle of material is completed right from the planning stage to purchasing stage to warehousing and finally distribution. And of course, the quality part and quality control and quality assurance is covered. When the third day is uh, contributing toward the various cost effective techniques in maintenance, including proper and feasible inventory management, and also like operational efficiencies in maintenance and a related case study to it as well. So there is a lot more for the same. This is just the gist of what I have said. There is a registration link in the chat box for the same. If you are interested or even you are keen to know more about the course, our team at Udaan will get in touch with you. Please do register yourself. I guess we have questions coming on now. It's time for some questions to be discussed. I'll just So the first question to you is, as 737 Max are declared to safe fly again, what modification or changes do we expect in the MCAS software?
So from the EASA, I read an article this morning that from EASA, it is safe to fly again. But I think from the FAA side, they are pushing for another set of tests after their flight tests that were performed, I think, a month ago, where a week of flight testing was performed, and FAA is still not convinced about certain things that they are pushing Boeing to show or develop or change on their MCAS system, change on their software, and change on training requirements as well. So about what actually changed on the MCAS software, I am not aware, but there are changes being made to the software. But more importantly, there are changes being made to training and AFMS documents, pilot documents, and how um, real life trainings can be provided about the system and how to make sure you have enough training provided basically. And these are all the changes that I have seen thus far. If you look into how Boeing mentality towards design is and how Airbus mentality towards design is, Airbus always has a manual redundant system or a manual fallback system as the
Mhm.
final go, but Boeing does not have that. It's just how the mentality and culture affects both of the aircraft design, and this is the way the Max has been designed. We are all glad that the Maxes are, at least from the European side, it's flight, safe to fly again, and we are all waiting for the Max to take to the skies again.
Absolutely, absolutely. It's a very beautiful aircraft.
Yes,
Personally, I am uh, like those winglets are something new for me, and it's like eye catching. So the
yes,
next question we have from Abhinav is, it would be great if you can share how our advanced technologies like virtual reality or 3D simulation using digital twins are being used by design engineers.
absolutely. I think there was one customer where he was looking into virtual reality. We actually, for the first time for testing, purchased Oculus, I think it's called, glasses, and we had to be trained with using virtual reality on what the person wanted to see is. Um, the person wanted to be a pilot, but the family did not let him be a pilot. So he wanted to make sure that he sees what the pilot sees from his cockpit and simulate all of that in his virtual reality glasses, and see if he can perform what the pilot needs to perform based on complete virtual reality. And so we had to, I wasn't involved in it more than just that, but yes, for pilot training, for simulations, for even from the customer side, you don't hear about how the customers use virtual reality. We are always interested in how the pilots can use virtual reality for training and all of that. Yes, it is being used, it is being looked into. um, Good question, and I will have to look into that more on where some of those developments are and probably get back to you on it.
Sure,
But
sure.
yes, it is being developed.
Yes, yes. Uh, Another question is, in Gulfstream, you have touchscreen switches for the overhead panels. So how do you place the traditional play cards on the touchscreen?
So on touchscreen, when it comes to touchscreen, your maintenance manuals need to be updated, right? So if you cannot just take a Gulfstream 450 maintenance manual, if the particular technician has only worked on the 450s, then it's not going to be easier for them to work on the Gulfstream 500, 600. The maintenance manuals need to be updated where they see every particular screen
Hmm.
on as screenshots on their particular page, and they go through with that, right?
Right.
So at Gulfstream, certification and human factors is always taken very seriously, and especially for these new projects, the technicians and the installers were also being involved in the TC design, because at the completion side STC, you cannot just go ahead and change these touchscreens and work on avionics, right? So
Right.
most of that has to be done on the type certificate design. And yes, a lot of technicians and maintenance engineers had to undergo hours and hours of training before they are capable or certified to work on the G600. I still remember that I was at a G650 hangar or a 550 hangar, and every week or every 2 weeks, one particular production floor team would be gone for their training. And they did that in rotations, where at the end of 6 months, when all the production teams were highly trained on the 500s and 600s, that's when they introduced 500 600s into our hangar. And so placards go away when you have touchscreens, and then updated manuals come into play, where you are given screenshots of every touchscreen options that you see and how to get there as a manual, and you need to be trained on.
Yeah. And a small addition to the question from my side. You have certain switches like the engine kill switch where you have duplicate security when you just pull up and show. Also, some firefighting switches where you just switch the knob to right or left to trigger it. How do you overcome those in touch screen systems?
Those are not touchscreen, right? So
Okay.
some of those, yeah, those are
Right.
not touchscreen. Some
Right.
of those are still mechanical switches. Gulfstream 650s have a rat,
Mm-hmm.
ram air turbine. Those are
Mm-hmm.
again mechanical.
Mm-hmm.
So those may be going into touchscreen for the G700 or further.
Right.
But as of now, this was a big shift for Gulfstream from the 650s with the
650.
traditional cockpit to the 500 600s with with the incorporation of touchscreens all over the cockpit.
Absolutely, absolutely. Another question just coming to my screen is many say that fly by wire have removed the natural feel of controlling an aircraft. What are the downsides and benefits for the same?
So, I mean, fly-by-wire, as you guys may know, that it is a technology or system that has been there for a while now,
Mm-hmm.
right? So it's not like in the last decade. Things have been in work for a fly-by-wire system for a while now, and
Mm-hmm.
all the latest FedEx or flight management computers, FMCs, avionics, everything is based around a fly-by-wire model, and for efficient, discrete communication uh, between the systems, right?
Right.
So again, I think this is a preference where trust in automation comes into play. But more importantly, when you use fly-by-wire, I remember working on the Boeing 787, where EWIS was given the highest importance. And initially I started working for wiring in for galleys and non-essential systems, and then more and more I started working on the avionic systems, fly-by-wire.
Mm-hmm.
um, you know we think about the system on the software side of things, and we don't think about the wiring side of things, right? So
Mm-hmm.
we also want to make sure that, is it wired properly? Is it are we using like the certified wire for a particular system?
Mm-hmm.
Have we calculated voltage drops properly? Have we
Right.
calculated EMI EMC interferences properly? And once you have all of that, the system is going to perform like it's supposed to perform, right? Of course, there are going to be mishaps and everything happening,
Mm-hmm.
but trust in a fly-by-wire and what goes on to a fly-by-wire system is much more than just a software and a computer, because again, wiring comes into play,
Mm-hmm.
installation comes into play, and there are so many aspects that have to work properly for the fly-by-wire system to work properly,
Right.
and that's more important.
Absolutely, absolutely. So we'll have a couple of more questions. Being a quality engineer, I couldn't stop thinking about process-based approach in AS 9100. Every time you mention holistic system thinking, what can design and quality engineers do to align instead of having their own internal process?
Hmm, good question from them, huh? So it is, from a QC perspective,
Mm,
um, when design engineers finish their design, you hardly see some of them on the aircraft to complete through. And only then will, some QC inspectors would be like, why is this designed this way? This could have been certain,
mm,
or this could have been done in a different way where I could have found my quality better. Or your documentation should have provided certain information which is probably going to be useful for me, instead of me having to either like assume or go behind some project engineers to make sure that certain quality requirements are met from your documentation, or from how the particular quality aspect is being met.
mhm,
This is from the quality side, it's always tricky, where design engineers, of course we are not going to go through this AS 9100 things. We're probably going to be bored out of our head reading all of those things, but for quality engineers, that's their bible, right?
mhm,
So again, there is a communication gap, which is like, hey, you don't have to understand all of the AS 9100
mm,
policies or requirements, but here are certain things that I expect as quality guy or QC
mhm,
that I need to see on your particular drawing or your particular documentation. And once you have that kind of communication and they understand why they have to put in a certain information, or how to improve their drawing, again, it's just communication between what is required. You can't just tell them, I want to make sure you understand all the 1,000 pages of a document, but then if you rather break it into what in these 1,000 pages are important for the design engineer, and then let them know, here is what I need from your document or from your design or from the process to make sure my job is done easier, or to make sure the QC process is done better. And here is, we have done that, where since I always go and talk to I'm always on the floor. I'm always on the floor, always on the aircraft, um, always thinking like, what can I improve and what can I learn?
mhm,
And I've spoken to a lot of these QC people, and small things which you don't know if it's important or not, you just take off. So amongst design engineers, this is very common, where you know hey, this particular flag note has no implications because no one has ever asked me this question, so I'm going to take it out.
right,
But from the QC perspective, that's the only thing from that drawing which is important for you.
mm,
And if they took it out because none of them needed it, then that's communication problem, right? Because either they didn't know why there was in the first place, and from the QC perspective, you never communicated why it was required. So
mhm,
once you have a QC training on, here is the 10 points I need from the design team, eh, that problem that you were talking about goes away. And that's again a holistic systems thinking approach. If I hope
mhm.
I answered your question.
Absolutely, absolutely. Just a last question. As you mentioned about your research based on simulation from pilots and controllers, like one of the participants is asking, what parameters are you looking for when it's relayed on the ground? Does it have any implications from human factor point of view?
Absolutely. So the interface matters, like
Mm.
what the avian, are you like, can you ask them if they're talking about from the ground control side or the tower side or the pilot side?
I guess
So
it's
let me
common
talk
for
on the ground
everyone for
control
a
side, right?
yeah, ground set.
So from the ground side, it is what interface are you using?
Hmm.
Is it coming on the right direction? Are we using, uh, you know, so we have this synthetic voice system where you, if you put in some details, somebody is going to, it's automated that somebody is going to talk
Hmm.
on the screen on the pilot or from the tower control. So if you are working on a system or a particular user interface where the user interface does all the things, and you as a ground control, as ground control, you don't do anything, right? You don't have to do anything. You loved your job because you were doing 50 different things on the UI, and now you go from 50 different things to just two things, you are bored out of your head, right? Because you don't know what to do because system is taking care of everything. Human factors again. How much are you trusting the system? Because even now when you think about a regular um, depositing your check from your phone versus going to the bank and depositing your check, trust in automation is very, a lot of people still
Right.
don't go to the, still go to the bank to deposit their checks, right? So that happens everywhere. And then with respect to the screen itself, is the UI being user friendly, right?
Mm,
When it says, say for example, an issue is happening and a troubleshooting message, and there's supposed to be a troubleshooting message that pops up, right? If the troubleshooting message doesn't pop up on your screen, and you have to actually go through two layers of clicking to get to a troubleshooting page, then that's not a good design, right? Because you don't know when you don't know when an issue is happening, and you don't know when you have to go to that troubleshooting page to understand that there is an issue, right? But
mhm,
rather, if the issue pops up on your screen, then you understand that, okay, there is an issue, let me work on it, right?
mm,
So these are some human factors for the ground control systems as well, which mostly trust in automation, the UI especially, and the training. If a particular troubleshooting issue comes up,
mm,
what do I go press? Is that really user friendly, right? If I don't understand, say for example, main page, um, issue one, like say for example issue one, and then you go issue two, but if the main page says something which is not relevant at all to the second page, you don't know if you have to go into that page. And when an issue happens, you probably don't have enough time to go
mm.
keep clicking to find your particular thing that you need to do. All of these are human factors, and these are some of the things that I can think about uh, pertaining to your question.
Absolutely. Just a last question. As you are working with Wisat and it's been constantly updating the Wi-Fi system, so what are the challenges associated with applications of onboard Wi-Fi? And as a Indian market, it's constantly based on low-cost airlines. Is it feasible or viable for airlines to make an update over the time being?
Yes. So answering your first question about Viasat's challenges,
Mm,
right? The first challenge comes from satellite perspective, right? We have our satellites in the geostationary orbits or medium Earth orbits or the
mm,
low Earth orbits. Now that you see, Tesla's Starlink satellites, which work on low Earth orbits,
right.
and even in our Indian space, now that you see Pixar or
Mm,
Dhruva Aerospace, they are all working on satellite systems for the low Earth orbit and to provide internet to the Indian skies, right?
mm, mm,
And then, so satellites and where they are located play a big role. If Viasat's looking at um, world over coverage, then satellites need to be developed to make sure that we have a world over coverage, whether it's the North American region,
mm,
Asia Pacific region, Middle East and Africa region. Satellite development is in turn, is indeed one of the Herculean tasks that a company needs to go through to make sure that we have enough satellites that are developed.
mhm,
The next one, when Wi-Fi updates happen, is say for example your Wi-Fi equipment or ground terminal networks are all were all only used to, say for example, Viasat satellite 1, for example, right?
mhm,
And if you want to update to Viasat satellite 2 or Viasat satellite 3, it's not just about updating the satellite, right? It's also about updating the ground control terminals, the
mm,
network, to make sure it's compatible to Viasat 2 and Viasat 3. And it's not, since Viasat's world over, you have to go to every particular ground terminal. You have to, every particular antenna on an aircraft as it pertains to the aircraft, the antenna software needs to be updated. The antenna itself might need to be updated sometime to make sure it works with uh, Viasat 2 or Viasat 3
mm,
as and when we start updating our satellites, right? So these are some challenges. Next comes software changes, and we need to let customers know that they need to bring in their aircraft for a particular modification or upgrade to happen. Sometimes customers are okay with it, sometimes they are like, hey, I cannot eat up for the downtime, I need Viasat to pay for it.
Mhm.
Sometimes we need to eat up the cost on because customers cannot afford a downtime because this person may be busy every day flying all over the world signing business contracts,
Mm.
right? So now we need to schedule an aircraft downtime. Certification comes into play. PMA updates, FAA comes into play. So there is this whole array of um, teams and processes that needs to work together to make sure a Wi-Fi update happens, not just from the Viasat side, but from the customer side as well. Now, for the Indian market, yes, it is a huge market, of course, and every satellite company, whether it's Viasat or Intelsat or Eutelsat
Mm.
or OneWeb, everyone's vying for the Indian market or the Chinese market because these are huge. But again, this low cost has a big impact because we cannot make as much as we make here in the US or outside of US because of the low cost carrier competition.
Right.
But it's also about regulations, right? A reason why outside satellite members couldn't enter the Indian satellites is because of security.
Mm.
Because once you get into satellites, it's a national security problem, right? You don't know what's being involved in the satellite. And Indian market or Indian civil aviation is, but it's growing there, right? More outside foreign investments are coming in. There are more investments or interest towards integrating the Ministry of Civil Aviation and our own communications and external affairs ministries to go make sure that other satellite communications from foreign, we can
Mm-hmm.
work with foreign satellites, right?
Right. Right.
It is a big thing, national security issue, but we hope it goes away because every company is buying for the Indian satellites.
Right.
And the other one is the low Earth orbits, right? Because we
Mm.
all look for the least cost for Wi-Fi on our thing. I think last week I read about Reliance coming into the in-flight entertainment industry, which
Yes.
is a huge thing because you have a big company eyeing for in-flight entertainment, and once you have such developments happening and big investors coming into the play, you're probably going to see big names from the satellite industry coming to work with them, and that's a positive sign for the Indian skies.
Absolutely. We hope for the best. So yes, that's it for now. If any of the participants have any of the questions, please get in touch with us. We will forward it to Mr. Arjun and we'll get back to you within 48 hours. That's what we can say for now. Also, there is a feedback form for the webinar in the chat box because feedback is equally important for every one of us because we need to like advance every week by week for us. So please show your honest feedback in the form and please bear 2 to 3 minutes for it. We could come up with something better as your expectations. So moving on with the presentation. Yes, as a cultural part at Udaan, I would request everyone to switch on their cameras for the final photograph, which we have a virtual sort of photograph. So I would request all participants to please switch on their cameras for a couple of seconds. We could have a quick photograph for the same. Yeah. I guess it's sufficient. Thank you everyone for the photograph session. Moving on to the last part as a vote of thanks. I would officially thank Mr. Arjun on behalf of Udaan Aviation for delivering such an productive and informative session on this Sunday. Also, our director, Mr. Subhashish Modak, for arranging this sort of webinars. Our backend team, Tanmay and Nikhil, without which it is never possible. Uh, our knowledge partners, as you can see on the screen, HIMS Education, Streamline Aviation Academy, GMR Aviation Hyderabad, Eagletronics, and our parent company, Trace Passes Eco Solutions Private Limited. Last but not the least, I thank each and every participant who have come up and joined us on board this productive seminar. I hope it was something noteworthy, and we assure you the same and even more productive in next upcoming futures. I wish you a very happy Sunday and a happy Navratri to all of this in this festive season. I hereby conclude this session and thank you so much for joining us with Udaan. Thank you. Thank you, everyone.
Thank you, guys. Thank you for this
Thank you.
opportunity.
Thank you, Arjun.
Thank you.